Hello, my dear mechanical champions. How are you all? What's up? कैसे हैं सब लोग? Please, guys, do join me fast so that we can start our wonderful session on time. This is Chandrashekhar welcoming you all to the India's largest, the best, and your favorite live learning platform, that is BYJU'S Exam Prep. And you guys are watching me live through the beautiful series on heat and mass transfer. And in this series, we are having the detailed discussion about the radiation mode of heat transfer. Yesterday, we talked about the various parameters related to radiation like emissive power, radiosity, insolation or irradiation. Other than that, we talked about the various radiation properties like absorptivity, transmissivity, and reflectivity, and emissivity. And also we had talked about the concept of the black body. Hi Setupati, good evening, welcome. Namaskar, Adab, Shubh Sandhya. Good evening, Sat Sri Akal, Assalam Walaikum, Wanakam. I hope everyone is safe and sound. So first of all, please guys do let me know if my audio and visual quality are all clear or not. Am I audible and visible to everyone perfectly? Keep on responding through the comment section. Today's session is all about the radiation shape factor, which is very important part of radiation analysis. Without understanding the shape factor, you will not be able to understand the analysis of the radiation, or we can say without understanding of the shape factor, the radiation is incomplete. And let me tell you very honestly that so many students, 70-80% of the students are having the wrong information or the wrong concept about the radiation shape factor. So I will try my level best to make you understand, to make you comfortable in the understanding of the shape factor. Alright, and before understanding the shape factor, you need to know about the radiation intensity. So first we will talk about the intensity of radiation, and then we will enter into the radiation shape factor. Please do let me know, what do you know about the radiation shape factor? What is the significance? How do we define? What are the other names of radiation shape factor? Everyone, please do respond. I cannot see the comments. Are you guys talking to me or not? So let me quickly introduce myself for those who are meeting me for the first time. My name is Chandrashekhar, Mechanical Engineering graduate from IIT Delhi, and also cleared the Engineering Services Examination, worked in SAIL, and from last 9+ years or close to 10 years, I am completely into teaching, guiding the young generation for achieving their desired objective in competitive examination, and these are my areas of expertise which I am comfortable with. And I would strongly recommend all you to join me on the Telegram group. The link is there on the screen. Once you will become part of my Telegram group, that is Mechanical by Chandrashekhar, and the link is also there on the screen, you will be getting the important exam notifications. You will be getting the PDFs and the notes of all the classes which I take from time to time, and you will be getting the updates about all the free sessions which I bring for your benefit on YouTube channel as well as the BYJU'S app. And I am also started giving you the important question daily doses, and there will be doubt clarification. So I want everyone to solve those questions which I provide to my Telegram group, so that it will help you to understand the concept in a better and interesting manner. Hi Sairam, good evening, welcome. People do not talk to me. Why? And along with the free sessions, we also provide the paid classes. You can see the students who have achieved their desired dream with our guidance and their hard work. You can also become the topper if you join us through the guidance program which is given by BYJU'S Exam Prep. All right, and if you have not liked the session yet, I would request everyone to like the session, so that the session reaches to all the mechanical engineering aspirants who are preparing for GATE examination or any other competitive examination. And if you are new to this YouTube channel, Please do subscribe so that you will be getting the notifications of all the free classes. Sairam, the answers. Yes, I will share the answer. The answer to both the questions are A. First question, the correct answer is option A. Second question, also the correct answer is option A. These are the answers for the daily doses. All right. And if you have any doubt in solving those questions, you can just mention your doubt in the Telegram group. I will be giving you the detailed solution as well. These are the challenges of life. Everybody is need to prioritize your preparation. You should take out some time to focus on your preparation, because if there is a discontinuity in your preparation, definitely it will impact your final result. So even if you are getting very less time, it is all fine, but continue your preparation as well. So what we are going to discuss in today's session, this is the index or the things which we are going to talk about. One is the radiation intensity, I. What is the unit of radiation intensity? Can anybody let me know the unit of intensity of radiation? I keep on asking you the questions so that the more you share your knowledge, the more improvement you get. And then we will be talking about the solid angle denoted by omega. This is the notation for solid angle. What is the unit of solid angle? What is the unit of solid angle? What is the unit of, then we will talk about, because without understanding the concept of solid angle, you will not be able to understand intensity of radiation. And once you are comfortable with solid angle and intensity of radiation, then we will enter into the most important topic of radiation, that is the shape factor, the definition of the shape factor, the physical significance of the shape factor, how to define, what is the need of defining this shape factor. Everything we will talk about the shape factor, and then finally we will be talking about the various properties of shape factor. Yes, hi RPS Inspired, good evening, welcome. The unit of solid angle is steradian. Shall we start? Shall we start our session? There is a question on the screen. Please keep your notebook, calculator. Calculator may not be required, but still you should always keep your notebook, pen and calculator along with you whenever you are going to appear for any live session. It is going to help you to write the important points. It will help you to solve the questions. It will help you to improve yourself by attending the class with your full dedication and full effort. Yes, yes, Sairam, very nice. I am quite impressed. The question is there on the screen. Yes or no? Is the statement true or false? Is the statement correct or not? Shape factor depends on the temperature of the surfaces for which we define the shape factor. Is it a function of temperatures? What will be your opinion about this? Okay, so let us start. Let us start talking about the intensity of radiation. Can you just let me know, why do we define the intensity of radiation? What is the need of intensity of radiation? Sairam is only responding. What about others? Either you don't know the answer or you do not want to disclose your answer. Rakesh, yes. Rakesh and Sairam are saying no. What about others? So why there is a need of defining the intensity of radiation? If you remember, yesterday we talked about the emissive power. That was the total emissive power. We talked about the radiosity. That is actually the total radiosity. We talk about the insolation. That is the total insolation or the total radiation incident on a surface per unit time per unit area. The unit of these parameter was watt per meter square. I hope you are comfortable with these three parameters: emissive power, radiosity and insolation. I had given you one example of bank account to make you understand these three parameters in a better manner. Emissive power is like your basic expense. J, radiosity is like your total expense, that is basic plus luxury, and insolation or irradiation is like your income, which depends on your employer. If your employer is very rich, then your income will be high. If your employer is not that rich, if your employer is not getting the profit, then you will definitely get the lesser salary. Yes, so these parameters do not talk about the direction. Direction is missing in defining these parameters, because we define the total emissive power, total radiosity, total insolation. So the direction is missing in these parameters. To include the direction into consideration, we need to define the intensity of radiation. How do we define the radiation intensity? Denoted by IN in the normal direction. The unit is watt per meter square steradian. So look, there are two surfaces. Can you see these two surfaces? One is radiating surface A, one is radiating surface, and two is the receiving surface. And their centers are joined by a line which is having a distance r. R is the distance between these two. And the heat transfer or the radiation heat transfer from 1 to 2 is going in this direction, that we can define del Q 1 to 2. The radiation leaving the surface 1 and reaching 2 is del Q 1 to 2, because the areas are dA1 and dA2. We are talking about the small areas dA1 and dA2. So how do we define? N1 is the normal to dA1, N1 is the normal to dA1, and N2 is the normal to dA2. There are two surfaces where the radiation exchange is taking place. These are the two surfaces between which radiation exchange is taking place. Surface 1 having the area dA1, the normal to dA1 is N1. Similarly, there is another surface like this, another surface, that is the area is dA2, small surface, and the normal to dA2 is this. And the line joining dA1 and dA2 is denoted by R. So the radiation intensity is the rate of radiation per unit surface area of the radiating surface through unit solid angle in a particular specified direction. That is how the intensity of radiation is defined. So the rate of radiation, that is watt per unit surface area, that is per meter square, and through unit solid angle in a particular specified direction, the unit of solid angle is steradian. That is how the intensity of radiation is having the unit watt per meter square steradian. So this is the expression for radiation intensity between 1 and 2 in a normal direction. So the ratio of del Q1 to 2 upon dA1 cos theta 1, there are three terms you can see. One term is in the numerator and the remaining two terms are in the denominator. Let us talk about the significance of each of these parameters. What is del Q1 to 2? One is the radiating surface and two is the receiving surface. Del Q from 1 to 2, this is del Q1 to 2. Del Q1 to 2 is the rate of radiation from 1 to 2. dA1 to dA2, the unit is watt or joule per second. And dA1 cos theta 1, what is dA1 cos theta 1? dA1 cos theta 1 is the projected area of a radiating surface, that is dA1, onto a plane perpendicular to the direction of radiation. This is the direction of radiation. If we draw a perpendicular to the direction of radiation, this is the perpendicular plane. This is perpendicular. This is the perpendicular plane which is the perpendicular to the direction of radiation. So the projected area of dA1 on a plane, theta 1 is the angle between direction of radiation and normal. Theta 2 is also the angle between the direction of radiation and normal for surface 2. So dA1 cos theta 1 is the projected area of the radiating surface dA1 onto a plane which is perpendicular to the direction of radiation. I hope you have understood it. Is this clear? The unit is meter square. That is the projected area of the radiating surface onto a plane which is perpendicular to the direction of radiation. Now the solid angle. The solid angle is the angle subtended by the receiving surface at the center of the radiating surface. That is known as solid angle. What is the solid angle? If I try to show you the solid angle here, the solid angle is the angle which is subtended by dA2 at the center of the radiating surface. This is the solid angle, three-dimensional angle. This is the solid angle. This is dw or d omega. This is the, are you able to understand it? So that will be dA2 cos theta 2 upon r square will represent the solid angle which is subtended by the receiving surface. This is the receiving surface at the center of the radiating surface, and the unit is steradian SR. Is this clear? So the ratio of rate of radiation per unit projected area of the radiating surface per unit solid angle is nothing but intensity of radiation, that is watt per meter square steradian. Why do we need to define the solid angle? Solid angle is all about three-dimensional. For an example, if we talk about the plane angle, the pizza slice, a slice of pizza is defined by a plane angle, that is alpha. Alpha is the plane angle because it is two-dimensional figure. Pizza is a two-dimensional figure, so the plane angle alpha is defined, or alpha can be calculated, that is the plane angle, is the ratio of arc per unit radius, isn't it? Arc per unit radius is nothing but alpha, that is the plane angle. But if it is a three-dimensional figure like a slice of watermelon, so then we need to define the solid angle. The area of this surface is A, and it is making an angle, making a solid angle omega at the center of the watermelon. That is called as solid angle omega. So this is the area A, and this is the radial distance R. So omega, that is the solid angle, is the area A by R square. That is how the solid angle is defined. This is omega. I hope you have understood it. If anybody is having any doubt in understanding the plane angle and solid angle, the unit of plane angle is radian. The unit of plane angle is radian, and the unit of solid angle is steradian. Area per unit radius square. Area per unit radius square. Is this clear to everyone? Anybody is having any doubt? Now, if we integrate this intensity over a hemisphere, if we integrate this intensity over a hemisphere, why we need to integrate it over a hemisphere? Because the electromagnetic waves are radiated by a surface in the hemispherical region over the surface. The electromagnetic waves are radiated by a surface. For any surface, it is radiated in the hemispherical region over the surface. If we integrate, this is how the radiation is radiated by a surface. So if we integrate over a hemisphere, I am not getting into the technicalities or the derivation part, but you need to understand, if we integrate over a hemispherical region, then we can say the total emissive power of a real surface is pi multiplied by intensity of radiation for emitted radiation. That is how, that is the relation, pi times of intensity of radiation. Also from here, yes, E is equal to pi in, E for emitted. For a black body, we can say pi into in for the black body. That is how the total emissive power can be defined. If we want to find out the total radiosity, then also pi multiplied by intensity for emitted plus reflected. And we can also define the total insolation, that is pi multiplied by in for incident radiation, I for incident. That is how we can define, we can relate the intensity. The unit of these parameters are watt per meter square. Watt per meter square. Isn't it? Is this clear? Now, let us move little further. Now, how to define the radiation shape factor? Why there is a need of defining the radiation shape factor? First of all, you need to understand why do we require the shape factor. Look, the radiation heat exchange between two or more surfaces. The shape factor comes into picture only when there are two or more surfaces having the radiation exchange. So the radiation heat exchange between, yes, for a hemisphere, it is the solid angle. Pi is the total solid angle for a hemisphere. Let me explain you this way. Give me a moment. Let us say this is the pizza slice we want to. This is the slice of pizza, not pizza. This is the slice of watermelon, and this is area A. This is the area A. The angle made by this area A, at the center of the watermelon, this is called as solid angle. The cone angle, this is called as solid angle. And for a hemispherical region, the solid angle, the total solid angle will be pi. Right? That is why the unit, that is how the unit is. Pi is having the unit steradian, SR, multiplied by watt per meter square steradian. So this steradian getting cancelled out. So the unit of these parameters will be, watt per meter square only. Is this clear to everyone? Please make some noise. Is this all fine up to this point? Now let us move to the more important, more wonderful part of the radiation, that is the shape factor. What I was telling you is the radiation heat exchange between two or more surfaces not only depends on their temperatures and the radiation properties like absorptivity, emissivity, transmissivity, and reflectivity, etc. So the radiation exchange between two or more surfaces not only depend on their temperatures and radiation properties, but also it depends on the orientation of those surfaces with respect to one another. So the radiation shape factor talks about the orientation of the two surfaces with respect to one another. It also depends on the orientation, how the surfaces are placed with respect to one another. Are the surfaces facing each other or they are at some angle with each other? How the orientation is there. All right. For an example, have you taken sun bath? Have you tried taking sun bath? Whenever we take sun bath, then we always lie down to take the sun bath. We do not stand to take the sun bath because the orientation, taking the more heat or more radiation from the sun, requires the particular orientation. The orientation will decide how much radiation from the sun will reaches to your body. So whenever we take the sun bath, we always lie down rather than standing. That is because of the concept of shape factor. All right. What are the other names for the shape factor? Can you just let me know what are the other names for the shape factor? Radiation shape factor denoted by F. The other names of radiation shape factor are, can you just name some alternative names for the radiation shape factor? It can be geometric factor, or what are the other names? It can be called as view factor. It can be called as orientation factor. It can be called as configuration factor. Whenever you are asked any factor in radiation, mostly 90%, 99% of the time, it will be shape factor only, or any other name, angle factor, etc. So why do we define the shape factor? The reason is it accounts for the fact that the entire radiation leaving a particular surface, the entire radiation leaving the particular surface, that is the radiating surface. Let us say one is the radiating surface. The entire radiation leaving the particular surface may not completely reaches or may not completely strike the other surface. Why? Because the electromagnetic waves always travel in straight line. I had told you in the first lecture that electromagnetic waves travel only in straight line. That is why there is a possibility some of the radiation may lost to the surrounding. There is a possibility there is some radiation may lost to the surrounding. So it gives us the information about the amount of radiation leaving a particular surface and reaching the other surface. This is the receiving surface. This is the receiving surface. So the amount of radiation leaving a particular surface and reaches the other surface is nothing but is calculated or measured by the value of shape factor. Is this clear to everyone? Is this clear? Now you need to understand, leaving is not equal to emitted. The radiation leaving from a particular surface, leaving is not equal to emitted, as well as reaches or striking is not equal to absorbing. There are two different terms. The radiation leaving a particular surface is different and the radiation emitted from a particular surface is different. Similarly, the radiation reaching a particular surface is different. The radiation absorbed by a particular surface is different. So many students get confused with these two parameters or these two terms. They start assuming the radiation leaving from a particular surface is same as the radiation emitted by the surface, and they start thinking that the radiation striking or reaching the other surface is same as the radiation absorbed by the other surface. How to calculate the radiation which is leaving from a particular surface? Can anybody let me know? So how do we define? There are two letters used for defining the shape factor Fij. The first letter represents the radiation leaving the radiating surface and the second letter represents the receiving surface. So Fij is the fraction of radiation leaving the surface I which reaches the surface J directly. That is Fij. Fij is the amount of radiation or the fraction of radiation leaving a surface I and which reaches the surface J directly. That is important because there is a possibility that the radiation leaving the surface I but not reaching J directly, but it is reaching through some other source, through some other path, like the radiation leaving from I is striking to K and then it is reflected towards J. That will not be part of the radiation shape factor between I and J. If we want to determine the radiation shape factor between I and J, then we need to have I surface as the radiating surface and J is the receiving surface which is receiving the radiation directly from I. Are you getting it? So similarly, we can say F1 to 2 implies that the fraction of radiation leaving the surface 1 and reaches 2. That is not same as F2 to 1. F1 to 2 is not equal to F2 to 1, isn't it? They are not same. F1 to 2 and F2 to 2, they are having a different meaning. For F2 to 1, the radiating surface is 2 and the receiving surface is 1. I hope it is clear. Anybody is having any doubt, please do let me know. It is something like if the government is giving providing some free electricity or some freebies, then how much amount is actually reaching to the receiver? The fraction of that is nothing but the shape factor. Shape factor decide that how much amount is received by the other surface. So what is the range of the shape factor? Can anybody let me know? The range of shape factor between the two surfaces? What is the minimum value of the shape factor? What can be the minimum value of the shape factor? जितना गवर्नमेंट ने हेल्प भेजी, how much fraction is reaching to the needy, that is denoted by the shape factor between the government and the receiver. Because there is a possibility some of the help may not reach to the receiver, but it is getting consumed by other people. So that the limit of shape factor, what is the lower limit of shape factor? Can you just let me know? It is between 0 and 1. The shape factor lies between 0 and 1. What is the meaning of zero shape factor? Can anybody let me know? When we say zero shape factor, what is the meaning of zero shape factor between two surfaces? What is the meaning of zero shape factor? बताइए. Yes, RPS inspired. What is the meaning of zero shape factor? If we want to define F1 to 2, then we can say the ratio of Q1 to 2 upon Q1. That is shape factor between 1 and 2. Look, total radiation leaving the surface is Q1. The total radiation leaving the surface 1 is Q1. And amount of radiation received by 2 is Q1 to 2. The total radiation leaving the surface is, let us say, 100, but only 20% is reaching to the receiver. So the shape factor will be 20 by 100. Are you getting it? So the shape factor from 1 to 2 is the ratio of Q1 to 2 upon Q1. Can you just let me know how to write Q1 to Q1? How to write Q1? What is Q1? What is the unit of Q1? The unit of Q1 to 2 is also what? The unit of Q1 is also what? How to write Q1? How to calculate Q1? Who will tell me? How to calculate Q1? I am waiting for your response. Where are people? Intelligent people. Are they attending the session or not? How to write Q1? Anybody having any idea? Q1 is it E1 into A1? Will it be E1 into A1? Please do let me know. Will it be E1 into A1? E1 is the emissive power, A1 is the area of radiating surface. Will it be E1 A1 or not? Is this correct or not? Yes, Susan. Actually, the derivative of a function is nothing but the slope. So whenever we are touching the maximum point, then the slope will become 0. Slope is equal to 0. Even when we are touching the minimum point, the tangent will be horizontal, then also slope will be 0. So for maximum as well as minimum, the derivative is nothing but the slope of the function. So for maximum, for maximizing or minimizing, we need to have the slope to be 0. Are you getting it? And if we find out whether that is the maximum point or minimum point, we need to go for the second derivative. If the second derivative is negative, then it is a maximum point, maxima. And if the second derivative is positive, then it will be minima. Isn't it? Now, my question to everyone. Is this clear, Susan? Is this A1 into E1 or not? Let me tell you, it will not be A1 into E1, it will be J1 into A1. Because the radiation leaving from the surface and the total amount of radiation leaving the surface will be calculated by the radiosity at Q1 to 2. And J1 can be written as pi times of In into A1. Can we write J1 as pi In? Pi times of In, that is J1. into A1. And how to write Q122? Q122 can be written from here, from the intensity. From the intensity we can write Q1. Look, how to write Q122? We can say it is intensity which is constant and integration of dA1 cos theta 1 into dA2 cos theta 2 upon R square, isn't it? If we put the value of Q122 here, then what we will get? The shape factor. Can you write the shape factor F122? If we put Q122, this IN will get cancelled out with this IN, isn't it? So F122 is 1 upon A1, that is there. Then it will be double integration. Then it will be dA1 cos theta 1 into dA2 cos theta 2 upon, it will have pi also, pi into R square. Is this clear or not? This is how we can write F122. And similarly, if we want to write F221, I hope you are understanding it. If we want to write F221, then it will be Q221 upon Q2. So Q221 is intensity, then integration. It will be dA2 cos theta 2 into dA1 cos theta 1 upon R square, and divide by, it is pi times of IN into A2. I hope this is clear. Then we can have IN and IN getting cancelled out. So F221 is nothing but 1 upon A2, then double integration is, again it will be dA1 cos theta 1 into dA2 cos theta 2 upon pi R square. Is this clear or not? So F122 is not equal to F221, isn't it? But yes, A1 multiplied by F122 is definitely be equal to A2 multiplied by F221. Is this clear or not? A1 F122 is not equal to F221. So from these two expressions, we can say, from these two expressions, we can say F122 is not equal to F221. But what is that called? A1 multiplied by F122 is equal to A2 multiplied by F221. What is this called? Can anybody let me know what is that called? Any idea? I hope it is clear. If you have not understood it, I would request you all to go through the PDF once again to understand this concept. I will share the PDF in my Telegram group. That is why I want you to be part of my Telegram group. F122 is not same as F221, but A1 F122 is equal to A2 F221. That is called as, that is known as reciprocity theorem. That is called as reciprocity theorem. That is all about the shape factor. When the shape factor is 0 between the two surfaces, what is that meaning? It means the receiver is not receiving anything. The government is so corrupt, the people in the government is so corrupt that whatever the help given by the government, even a single penny is received by the receiver. That gives the value of shape factor between the government and the receiver to be 0. And what is the value of, what is the meaning of one shape factor? It means the receiver is receiving everything. No radiation is lost to the surrounding. Whatever the help given by the government, all the help which is provided by the government is actually going to the receiver completely. That means shape factor 1. It means Q122 is equal to Q1. When the shape factor is equal to 1, Q122 is equal to Q1. When the shape factor is equal to 0, I can write this way. If the shape factor F122 is equal to 0, implies Q122 is equal to 0. Means no radiation is reaching to the surface 2. When shape factor F122 is equal to 1, implies Q122 is equal to Q1. Whatever the radiation leaving the surface 1, all the radiation reaches to the other surface. I hope it is clear to everyone. If anybody is having any doubt, then you can just raise your concern through the comment section. Otherwise, we will proceed further to understand the various properties of the shape vector. I have already talked about some of the properties here. The first is the shape vector is a positive fraction, lies between 0 and 1. And the shape vector is independent of temperature and surface properties. It is not a function of T1, T2. It is not a function of alpha, emissivity, reflectivity, transmissivity, etc. So we can say the shape vector is neither a function of T1, T2, alpha, rho, tau, and epsilon. It does not depend on these parameters. Yes, Susan, very nice. Now the next point is its value only depends on, good evening Ranbir, why you are so late? We are about to close, but I would request you to watch the recording again after the session is over to get yourself more comfortable. And in tomorrow's session, we will practice some more numericals from the shape vector. That is also important. So whatever we are going to discuss today, we will have some practice session for the shape vector, because the shape vector is very, very important. So if it does not depend on the temperature and the surface properties, then the value depends on what? The relative shape, size, geometries, orientation of radiating and receiving surface. That is why the shape vector is a geometric quantity. Shape vector depends on areas A1 and A2. Shape vector depends on the orientation of those surfaces. Shape vector depends on the shape of the shape, size, geometries. That is why the shape vector is called a geometric quantity. And last point is very, very important. Whenever we define shape vector between 1 and 2, then we only consider the radiation leaving the surface 1 and reaching 2 directly. So the radiation which is reaching the surface 2 may be absorbed by the surface 2, may not be absorbed by the surface 2. Shape vector does not give us the information whether the striking radiation is absorbed by the surface or not. The radiation is striking the surface 2 does not need to be absorbed by it. Are you getting it? Absorption is different and striking is different. Also, if we are defining the shape vector between 1 and 2, try to understand this point also. This is surface 1, this is surface, let us say 2. And this is, let us say, surface 3. The radiation leaving the surface 1 and reaching 3, and then the reflected by 3 towards 2 will not be part of shape vector 1 to 2. What is shape vector 1 to 2? It is only the radiation leaving the surface 1 and reaching 2 directly. That is F1 to 2. This will not be part of the shape vector between 1 and 2. The striking radiation reflected from some other surface like 3 is not considered in the evaluation of shape vector between 1 and 2. Are you getting it? That is very, very important. Here, most of the people, most of the students have confusion in understanding. So, whenever we talk about the shape vector between two surfaces, one of those surfaces is the radiating surface. The total radiation leaving the surface Q1, that is J1 into A1, and J1 can be calculated by emissive power plus reflected radiation rho into G. J can be calculated by J is equal to rho E plus rho G, and then multiplied by area will give you the total radiation Q1, and Q1 to 2 can be calculated from the intensity of radiation. That is how the ratio of these two radiations is nothing but the shape vector. Now, further, let us talk about the other property of the radiation shape vector, that is called as superposition principle. That is the addition or subtraction of the shape vector. Now look, what is Q1? What is Q1? That is J1 into A1, isn't it? Q1 is equal to, the unit of Q1 is watt, the unit of J1 is watt per meter square, and the unit of A1 is meter square. So Q1 is J1 into A1. So we can say Q1 is directly proportional to A1. If we talk about the areas of the surfaces, more will be the area of radiating surface, more will be the radiation leaving the surface Q1. Q1 is directly proportional to A1. And also we know F1 to 2 is Q1 to 2 upon Q1. Or we can say Q1 to 2 is equal to Q1 into F1 to 2, isn't it? and Q1 is proportional to A1. So can we say Q1 to 2, can we say Q1 to 2 is proportional to A1 F1 to 2, isn't it? Q1 to 2 is proportional to A1 into F1 to 2. Is this clear or not? Isn't it? Do you guys agree or not? Please write why or no, yes or no. So we can say Q1 to 2 is proportional to A1 F1 to 2. Now, if we talk about the radiating surface 1 and this is the receiving surface 2. 2 is the receiving surface which is having area 2A and 2B combined together is, so whatever the radiation leaving the surface 1 and reaching 2 is nothing but the sum of radiation leaving 1 and reaching 2A plus 2B. So if we define Q1 to 2, then we can say it is sum of Q1 to 2A plus Q1 to 2B, isn't it? According to energy conservation, one is the radiating surface and 2 is the receiving surface. One is the radiating surface, 2 is the receiving surface. So Q1 to 2, if we want to write according to energy conservation, let me write the energy equation. If we write the energy conservation, so can we say whatever the radiation leaving 1 and reaching 2 is equal to radiation leaving 1 and reaching 2A plus the amount of radiation leaving 1 and reaching 2B. Sum of these two will be Q1 to 2, isn't it? And Q1 to 2 is proportional to A1 F1 to 2. So we can say it is A1 F1 to 2 is equal to Q1 to 2A is proportional to A1 F1 to 2A plus Q1 to 2B is proportional to A1 into F1 to 2B. If we simplify this, A1 are getting cancelled out. So the final expression is the shape factor from 1 to 2 can be written as the sum of shape factor from 1 to 2A plus the shape factor from 1 to 2B. I hope it is clear. That is how the addition of shape factor can be developed. Addition or subtraction of the shape factor can be developed. That is called as superposition principle. That is from the energy conservation equation only. I hope it is clear. Now, if this is clear to everyone, can you guys give me the answer for next example? Can you just let me know the answer to the next example? There is a question, there is a figure given. 2 is the receiving surface, the area is A2, and the radiating surface is 3 plus 4, that is A1. This is the radiating surface 1 and this is the receiving surface 2. Now, if we talk about the energy conservation, look, the radiation leaving the surface 3 and reaching 2 plus the radiation leaving the surface 4 and reaching 2 is nothing but the radiation leaving from 1 to 2, isn't it? Can we say energy equation? Can we write the energy equation to be Q1 to 2 is equal to Q3 to 2 plus Q4 to 2. Do you agree or not? Q1 to 2 can be written as Q3 to 2 plus Q4 to 2. And from the relation, we can say Q1 to 2 is proportional to A1 F1 to 2 is equal to Q3 to 2 can be written as A3 F3 to 2 plus Q4 to 2 can be written as A4 F4 to 2, isn't it? And A1 can be written as A3 plus A4. So the final expression is A3 plus A4 multiplied by F1 to 2 is equal to A3 F3 to 2 plus A4 into F4 to 2. That will be the relation to be used to find out any unknown. I hope it is clear. Here the area will not get cancelled out. Here the area is not going to cancel out, isn't it? Because the areas are not same. You need to understand how to write the energy balance equation. If you are able to write the energy balance equation, then you will be comfortable. Reciprocity theorem we have already discussed. So the shape factor from I to j, the shape factor from I to j can be written as 1 upon ai double integration cos theta I cos theta j into dai aj upon pi r square. That is what I have already mentioned. And from the above equation, ai fij is equal to aj fji, or we can say a1 f122 is equal to a2 f221, or if we want to write f122, then we can say a2 by a1 multiplied by f221. That is how we can relate these shape vectors, where a1 and a2 are what? They are surface area of radiating and receiving surfaces respectively. This is how the reciprocity theorem can be used. Is this clear? Is this formula clear? How do we got this formula? We got this formula F122 as Q122 upon Q1, and Q122 had been written by using the intensity. Now the enclosure theorem. What is enclosure? That is the closed curve. If it is a closed curve, if there is a three surface enclosure, let us say this is surface 1, this is surface 2, this is surface 3. The three surface makes an enclosure. It is an enclosure. So we can say from the energy balance equation, can we write the total radiation leaving the surface 1 is equal to radiation leaving 1 and reaching itself, plus radiation leaving 1 and reaching 2, plus radiation leaving 1 and reaching 3, because no radiation is lost to the surrounding, because it is an enclosure. Because of the enclosure, the total radiation which is leaving 1 is equal to Q11 plus Q122 plus Q123. And if we write Q1 is proportional to A1, then Q121 is A1 F121 plus Q122 is A1 F122 plus Q123 is A1 F123, isn't it? So from here, if we divide by A1, then what we are left with is, if we divide by A1, then we are left with, so implies F11 plus F12 plus F123 is equal to 1. That is called as enclosure theorem, which is applicable only when there is an enclosure. Similarly, for the second surface, we can write F221 plus F222 plus F223 is also equal to. Similarly, for the third surface, the radiation leaving the third surface will be used to write F321, F322 plus F323 is equal to 1. These are known as enclosure theorems. These are called as enclosure theorem, right? And then self shape factor. What is self shape factor? Fi to I. Self shape factor is actually the fraction of radiation leaving a particular surface I which strikes itself, which reaches itself. That is called a self shape factor. So if there is a plane surface, there is no possibility of radiation leaving the surface and reaching itself, because the electromagnetic waves travel only in a straight line. So there is no possibility of reaching itself. For a plane surface, the self shape factor will always be 0. This is the plane surface. Are you getting it? Similarly, for a convex surface, this is the convex surface. Similarly, there is no possibility of radiation leaving the surface and striking itself. They cannot travel in curved path. So for a convex surface also, self shape factor will be 0. But for a concave surface, this is the concave surface. For a concave surface, there is a possibility the radiation leaving from the surface and striking itself, isn't it? Even if they are traveling in the straight line. So for a concave surface, there is a possibility that the self shape factor can be non-zero. I hope this is all fine to everyone. One more concept, that is called a symmetry principle. When the surfaces are symmetrical with respect to each other, then we apply the symmetrical principle. Look, surface 2 and 3. Can you see the areas A2 is equal to A3 That is one thing. And the orientation of 2 and 3 is same with respect to 1. So 2 and 3 are symmetrical with respect to surface 1. 1 is the radiating surface and 2 and 3 are the receiving surface. So if the areas of 2 and 3 are same and the orientation are same, then we can say, do you agree whatever the radiation leaving 1 and reaching 2 will be same as the radiation leaving 1 and reaching 3. So Q1 to 2 is equal to Q1 to 3, isn't it? From the symmetry. From the symmetry, we can say Q1 to 2 is equal to Q1 to 3. Do you get it? Because they are symmetrical. The areas are same and their orientations are same. Are symmetrical or oriented? Symmetrically oriented. Let me write. 2 and 3 are symmetrically oriented. Surfaces 2 and 3 are having same shape, size and orientation with respect to 1. Oriented with respect to surface 1. So Q1 to 2 is proportional to A1 F1 to 2. Q1 to 3 is proportional to A1 F1 to 3. So A1 getting cancelled out. So F1 to 2 will be equal to F1 to 3. That is called as symmetry principle. That is called as symmetry principle. Are you getting it? That is known as symmetry principle. But for applying the symmetrical principle, the surfaces must be having same shape, same size, same geometries, same orientation with respect to the radiating surface. Then only we can apply the symmetry principle. I hope it is clear to you all. That is all from my side. There is a homework question. The one who will bring the correct answer to this homework question, it means you are quite comfortable with the shape factor concept. Tomorrow we will be having the numerical practice session. The question is find the shape factor for a long isosceles. This side is same as this side. This is also A, this is also A. Of a right angled triangular duct. This is a right angled triangle. And the surfaces are, this is surface 1, this is let us say 2, this surface is let us say 3. This is the enclosure. We need to find out shape factor F221 will be how much. This is your assignment question. Take the screenshot and do not forget to join me tomorrow at the same time for the numerical practice session for the shape factor that will give you the more in-depth understanding about the concept of shape factor. And if you have any doubt, you can always talk to me through the Telegram group or you can bring your doubts in the next session. I hope you guys have enjoyed the session. You guys have understood the concept of shape factor and intensity. If anybody is having anything to ask, you are most welcome. And this is my entire schedule. Tomorrow we will be talking about the shape factor algebra. Then we will enter into the analysis of radiation. And on 21st May, on 21st May, we will be going to have the quiz or Mentior for theory of machines and heat transfer. With this note, let me take your leave. If anybody is having anything to ask, please do let me know. Otherwise, let me take your leave. Enjoy your day. Take care. Enjoy your weekend with your family members. But do not forget to work hard towards your objective, towards your goal. Alright, do not be afraid of committing mistake because the mistakes teaches you more understanding, more knowledge. Mistakes gives you more knowledge towards your success. With this motivational saying, let me take your leave. See you tomorrow. Thank you. Stay safe, stay motivated and all the very best for your upcoming examination. Thank you guys. Jai Hind.